Hello everyone. So in the previous video we learned about continuous time LTI system and convolution integral related theory part, and here we are going to learn about continuous time LTI system and convolution integral related problems. So when you recollect the video, we have learned the equation which is x of t convolution h of t is nothing but integral minus infinity to infinity x of 2 h of t minus 2 d2, right? So we are going to apply these equation in order to find the convolution in different problems. So the convolution in time domain, that is in continuous time domain, can be found out by using two methods, that is analytical method and graphical method. So first we are going to look up the convolution using analytical method. Okay. So here I have taken two examples. So the first example is find the convolution of x1 of t is equal to tu of t and x2 of t is equal to u of t. So when you recollect that equation, you know x of t convolution h of t is nothing but integral minus infinity to infinity x of 2 h of t minus 2 d2. So instead of x of t and h of t, here we have x1 of t and x2 of t. So what will be the equation? It will be integral minus infinity to infinity x1 of 2 x2 of t minus 2 d2, right? You can also write this equation as integral minus infinity to infinity x2 of 2 x1 of t minus 2 d2. Now, how to choose between these two equations, that is integral minus infinity to infinity x1 of 2 x2 of t minus 2 d2, or integral minus infinity to infinity x2 of t x1 of t minus 2 d2. So consider example. If I have two signals with me, like x1 of t is a simpler signal and x2 of t is much harder signal or a complex signal. So for finding, if I'm taking a complex signal and finding t minus 2, it might get complicated, right? Or there might arise some mistake. So in order to avoid that, always take t minus 2, always find t minus 2 with a signal which is more similar. So I said my x1 of t is a similar signal and x2 of t is much complex signal. Now my equation will be, I'm going to write it as integral minus infinity to infinity x2 of 2 x1 of t minus 2 d2. Why? Because my x1 of t is a similar signal when considered to x2 of t. So that's why that's how you consider, you will decide how to use, how to choose between these two equations. Okay. So coming to this problem, I have taken, for me, u of t is much better. Okay, so my equation is integral minus infinity to infinity x1 of t x2 of t minus 2 dt. Okay, so I think you have got the idea how to choose between that two equation, that is integral minus infinity to infinity x1 of 2 x2 of t minus 2 d2 and integral minus infinity to infinity x2 of 2 x1 of t minus 2 d2. Okay, so in order to find this, that is integral minus infinity to infinity x1 of 2 x2 of t minus 2 d2, we have two parts, right? We have to find what is x1 of 2 and x2 of t minus 2. So how to find it? What will be x1 of 2? x1 of 2 will be nothing but just replace t part by 2. Okay. So what will be x1 of 2 will be 2 u of 2. So that is written here. Now what will be our x2 of 2? Our x2 of 2 will be, just replace t by 2, u of 2, right? But we don't need x2 of 2. For our equation, it is x2 of t minus 2. So what will be x2 of t minus 2? Just replace t part by t minus 2. What will be it? U of t minus 2, right? So that is here. x2 of t minus 2 is u of t minus 2. So we got this two part. Okay. So we reach, now one more step is remaining for finding out the convolution, that is the limit. So how to find out the limit? By considering this equation, so by looking at the first equation, that is x1 of 2 is equal to 2 u of 2, you will get that x1 of 2 is equal to 0 for 2 less than or equal to 0, and by analyzing this signal, that is x2 of t minus 2 which is equal to u of t minus 2, you will get this x2 of t minus 2 is equal to 0 for 2 greater than t. Okay. Now, how are we getting these limits? So when you do a lot of problems, you can just solve by looking these equations, that is our signal x1 of 2 and x2 of t minus 2. For the time being, it will be more clear when you go with draw the signal as a graph and analyze it. Okay, so our first signal is x of 2, which is equal to 2 u of 2. So first I'm drawing my u of 2. What will my u of 2? You know that u of 2 is a signal, is a unit step signal with amplitude 1 and is a causal signal. That is, it's a signal that is extending from 0 to infinity, right? So this can be drawn like this. Okay, now here I am multiplying my signal's amplitude by 2. So this 1 will be replaced by 2, right? That is given here. So 2 u of t or 2 u of 2 will be nothing but this signal with an amplitude 2 extending from 0 to infinity. Now when you look, our signal only exists for positive values of 2. Now when you come to the negative values of 2, our signal doesn't exist. That is, you can say for 2 less than or equal to 0, what will be negative value? You know, negative values are values that is less than 0. So for 2 less than or equal to 0, my signal doesn't exist, which means x1 of 2 is equal to 0 for 2 less than or equal to 0. So we got this part. Now analyzing x2 of t minus 2. So our signal is u of t minus 2. So u of t minus 2, don't find like this. You have to write like this, because we are considering the we are not finding in time domain, we are finding in tau domain. That is, in tau axis we are taking values, not in the t axis. So there might be arise a confusion. So you have to do it like this: u of minus tau plus t, or you can take it as u of minus of in bracket tau minus t. You can also do it like this. So what will be my u of minus 2? So I am doing it again step. So u of minus 2 is a unit step signal that extends from 0 to minus infinity. It is minus 2, right? With an amplitude 1. Now what will be u of minus tau plus t? So this is a signal with shift towards right with tm. Okay. So when you analyze the signal, or when you analyze this graph, you can see for tau values greater than t, our signal doesn't exist. So what I can say, x2 of tau is equal to 0 for tau greater than t. So we got the limit, right? We got the limit, that is our signal extends from, our convolution extends from 0 to t. So I can write integral 0 to t is so my convolution equation will be, y of t will be, my output will be 0 to integral 0 to t x1 of 2 x2 of t minus 2 d2, which is equal to, what is this x1 of 2? x1 of 2, what is the amplitude of x1 of 2? 2, right? So just replace x1 of 2 by 2. Now what is the amplitude of x2 of t minus 2 d2? It is 1, because we are not changing anything in the amplitude, we are just mirroring and shifting the signal. So the amplitude of x2 of t minus 2 will be 1 itself. So integral 0 to t 2 into 1 d2. Now what is the integration of 2? 2 square by 2, right? With limits 0 and t. Okay, so upper limit minus lower limit, which will be t square by 2 minus 0, which is t square by 2. So we got the convolution between these two signals, that is nothing but t square by 2. So I think you got an idea about how to tackle this question. The next method is convolution using graphical method. So this method is, so we are going to analyze this method by using an example. Okay, so our example is x of t is equal to u of t and h of t is equal to 3u of t minus 1 minus 3u of t minus 3, and find the convolution using graphical method. Okay. Now what in graphical method, what we are doing is, basically we are representing the signals in pictorial way, and I am keeping one of the signals stationary and the other signal is moved between the intervals of the stationary signal, and we are going to find the amount of overlap in each intervals, and by finding the amount of overlap between the each interval, we are finding the convolution in the intervals. Okay. So now coming to x of t, which is equal to u of t, and h of t, which is equal to 3u of t minus 1 minus 3u of t minus 3. So these are the signals we have to find the convolution using graphical method, right? So how will be our x of t, which is equal to u of t? So x of t is nothing but a unit step signal with amplitude 1, and it is extending from 0 to this is from 0 to infinity, right? This is extending from 0 to infinity. So we got x of t. Now next our signal is h of t, which is equal to 3u of t minus 1 minus 3u of t minus 3. Just take this part, that is take this signal and minus it in order to get h of t. So what will be our 3u of t minus 1? We know here we are so 3u of t minus 1 is nothing but the u of t, that is we are just amplitude scaling our u of t, and we are also right shifting it by an amount 1. So we are amplitude scaling our u of t with 3, and we are right shifting it by an amount 1 to get 3u of t minus 1, right? So the changes will be here. So our signal 3u of t minus 1 is nothing but 3u of t minus 1 is a signal with amplitude 3. If we are right shifting this signal by amount 1, right, that is shown here. The right shifting is shown here. So it will start from 1. So our signal will be from 1 to infinity. So 3u of t minus 1 is a signal with amplitude 3, and it extends from 1 to infinity. Okay, now what will be 3u of t minus 3? This is being what our signal is being, that is our signal u of t. We are getting our signal u of t is being what amplitude scaled by 3, amount 3, and it is being right shifted by an amount 3 in order to get what 3u of t minus 3. So we can say this signal's amplitude will be 3, and it will start from 3, right? It will be start from 3, that is shown here. So the signal 3u of t minus 3 is nothing but a signal with amplitude 3, and the signal exists from 3 to infinity. Now if you minus this signal, we don't want this and this, we want the subtraction of these two signals, right? So what will be, if you subtract this signal, you can see that this part will get cancelled, right? Because they have same amplitude. This part will get cancelled. Here 3 and 3 minus 3. But if you look here, the amplitude is 0. So this here the amplitude is 3 and here the amplitude is 0. So this part will be only remaining. That is, we can say our h of t is a signal which extends from 1 to 3 with an amplitude 3. Okay, so we got our two signals, that is h of t. So we got our two signals, h of t and u of t. Okay, now coming to our equation. So what is the convolution equation? Y of t is equal to x of t convolution h of t, that is equal to integral minus infinity to infinity x of t minus 2 h of 2 d2. So I said firstly, like, why I took this equation instead of h of t minus 2 into x of 2 d2. Okay, so our two signals should be so we got x of t and h of t. Pictorially we represent that, but we need here x of t minus 2 and h of 2, right? We need x of t minus 2 and h of 2. So what will be x of t minus 2? We know our x of t is a unit signal, that is u of t. Now what will be x of minus 2? It will be a signal with amplitude 1 and extending from 0 to minus infinity. Now what will be x of minus 2 plus t? So we know that it will be a signal which will be right shifted by amount t. So our signal x of minus 2 plus t will be of amplitude 1 and it extends from t to minus infinity. So this signal can be written as x of minus 2 minus t. So this signal can be written as this. So here is a bracket, okay. So this can be written like this, that is x of minus t minus t. We can write x of minus of 2 minus t. Now that is nothing but if you open the bracket, you will get x of minus 2 plus t, right? Okay. So we got our x of minus 2 plus t. Now I said we are keeping one signal stationary and the other is moved between the intervals, right? So I am keeping h of t, that is I am keeping h of t as stationary, and I am moving my x of minus 2 plus t between the intervals. Okay. So our h of t is a signal with amplitude 3 which extends from 1 to 3, and this is my signal x of minus 2 plus t which has an amplitude 1, right? So we are taking both the signals in one axis. Okay, so what will be this? So first we are considering the interval from 0 to 1. If you consider the interval 0 to 1, you can see there is no overlap between these two signals. So if there is no overlap, we can say the convolution between the two signals is 0. So that is written here. Now the next, so if so in the first case I took 0 to 1 interval. So the next interval should be 1 to 2, right? So the next interval is 1 to 2. So we are taking the signal from 1 to 2. So the our x of minus 2 plus t is being moved to right, that is from 1 to 2. Now you can see there is an overlap. The overlap is shown in green color. Now what will be the convolution? So the limit will be from 1 to t. So integral 1 to t x of t minus 2 h of t d2. So this will be x of amplitude of x of t minus 2 is 1 and that of h of 2 is 3. So this will be nothing but 3t minus 3. If you solve this, you will get 3t minus 3. Now we are again moving this signal from this x of minus 2 plus t towards the interval 2 and 3. So next we are moving from here. So this will be here. Now if you see again, the overlap is from 1 to t. So our this will be our convolution will be integral 1 to t 1 into 3 d2, that is equal to 3t minus 3. So you can see in the interval from interval 1 to 3, right? From interval 1 to 3 our convolution is same, that is 3t minus 3. Now the next will be from 3 to 4. So from 3 to 4 you can see the complete h of t is being overlapped by our x of minus 2 plus t signal. So we can say our limit is from integral 1 to 3 x of t minus 2 h of t d2 will be the convolution, which is integral 1 to 3 1 into 3 d2, that will be 6. Now if you go beyond this, that is if you take if you move the x of minus 2 plus t towards interval between 4 and 5, you can see the same convolution will come, because you can see as the signal moves, only this much overlap is being done by the signal. If you move towards the right, only that much overlapping is possible because the complete signal is being overlapped. So if you move like any interval towards the infinity, you can see the overlap will be same, that is the convolution is same, that is 6. So we can say our y of t is equal to 0 for 0 less than t less than 1. So that is shown because there is from interval 0 to 1 there is no overlap, and 3t minus 3 from 1 to 2 and 3t minus 3 from 2 to 3 intervals, and 6 for t greater than or equal to 3. So we can see here that for intervals 1 and 3 our convolution is same, 3t minus 3. So we can modify it as y of t is equal to 0 for 0 less than or equal to t less than or equal to 1, and 3t minus 3 for interval 1 less than or equal to t less than or equal to 3, and 6 for t greater than or equal to 3. So this is all about continuous time LTI system and convolution integral, and in the next video we are going to discuss about discrete time LTI system and the problems related to it. So thank you.